Hello everybody and welcome to a chat from the engineering desk. So we was buying stuff at the store today, and of course walked past the aisle with the rechargeable light bulbs. I thought, let's have a look inside another off-brand one. So I purchased one. The part that fits over here had been removed, and these wires used to go through this part, which had the PC board screwed to it, which faced inside onto the battery. Basically that set like that, that set like that, and the LEDs, which are upside down now, sit here. Now this has already got a board with some stuff on it contained on. It's already got this board, and at first I saw this and I thought interesting. Switch mode, there's an inductor, but there's another inductor. What I do find interesting is the provision for resistor additions or deductions over here. That is pretty interesting. And then turning this board around, it's busy. There's a lot of stuff going on here. Now it works in this the normal sort of operating mode for these things. You got two rings of lights, so mind your eyes. We have it's swamping out. We have the inner ring, and then we have the outer ring, which powers up on mains. So it's a pretty conventional type arrangement for which LEDs are lit when on mains and which are lit when on battery. It's got the usual flavor of 18650 stuffed into the base. £2,000 power. Very good. Now I've just fitted this switch top socket to the base. Turn it on. So let's have a look at the chips, because I see there are numbers on them over here. We know that's a rectifier. There's some capacitors, but there appears to be one chip in charge of the show over here. So what I'm going to do is I'm going to bring in the microscope, and I'm going to switch you guys over to that. Then we'll examine that chip. So here you go. Let's see, what have we got? The bright power 2513D. Pretty standard textbook stuff. Sorry, I battled this whole thing still. Let's see battling to hold it still. Anyhow, so that's a bright power chip. We got the gist of it there. BP 2513D. So there we go. Okay, put that aside and swap back the camera. The thing I like about this is the separation that this provides between the hot bit and the electronics, because it sits over here. Those two tangs are screwed into here like that, and the other two screwed onto this guy over here. Yeah, they're the mounting holes over there, like so. So your electrolytics and stuff kept away from the heat, which is very nice. Alexa, please stop playing. Sorry about that. It was unexpected. At least she's obedient. I don't know what she understood as play jazz. That's hilarious. So this was about $10, $9 or $10. Not terribly expensive. I imagine I would have to run a test to see what sort of autonomy you get out of this battery and what sort of voltage it charges it to. It would be sort of an extended test type of thing. Now those I imagine are the resistors for the operation when on battery. So perhaps what we can do is just grab the multinational meter. Bear with me one moment, please. I'm not far away, don't panic. May you have it close at hand. There we go. Okay, now I'm going to probe across these over here. Well, let's measure the resistance. Let's see what we got going here. Yeah. It's about an ohm. I imagine this stuff's all in parallel. Indeed it is. So when I measure on the blank pads, I measure those resistors. I'll quickly put it back onto microscope view and let's see the values. There you go. Turn the microscope all the way around. There we are. There's your resistors. So that explains the resistance we're measuring. Okay. Go back to that view. Let's measure the voltage across them. And I can work out the current. probably won't be much voltage, so I'm going to select 2 volts over here. And what I'm going to do is you guys watch the voltmeter, and I'm going to move this aside so I don't blind you. Blind myself instead. Yeah. Let's see what voltage we get. Yeah. 0.518 across those resistors. Put that back. So put multinational meter aside. So let's work that out. Alexa, what is 2.7 divided by 3?
2.7 divided by 3 is 0.9.
Thank you. 0.9, and we had about half a volt through that. Alexa, what is the current through a 0.9 ohm resistor at half a volt?
From studylib.net. The ammeter shows that the current, though it is 0.07 A.
Okay. So we got 0.5. We want to Ohm's law, so we're going to times it by 0.9, 0.45. That seems reasonable enough. Let's count these LEDs. 1, 2. How are they numbered? Yeah, that's interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, so 450 milliamps divided by 12, 37.5 milliamps per LED. So that's a reasonable amount of light. So if you go and fiddle around with that, you could reduce that value, which will make your LEDs last longer and make this last longer, all of which is very good. I'm not going to re-engineer this circuit. They're fairly generic. We pretty much know what's going on here. But it's interesting to see the different design sort of formats and structures that they use in these lamps. Because I've now taken apart a third one, and they're all pretty different. We had the Philips and the what is this called? Lightworks. The Lightworks, and this is a Spar brand lamp. Globe Emergency. It's branded for Spar. But it's not bad. It really isn't bad at all. I like the fact that this has been well designed with heat management in mind. What is the light output of this? 9 watts. Yeah, not bad. I'm presuming that this is not a constant current driver for the battery operation. It merely uses those resistors to limit the current through the LEDs. So far the Philips has been the only one that I've seen where they're using a buck converter to actually run the LEDs. This is more cost effective and it works. It's not the end of the world. So if you want to spend about 50% more, then you get a lamp with a buck converter in it and you get constant light output while this discharges. While with these it sort of tapers off. It also works. You can still see what you're doing. And I think that's going to wrap it up. This was nice. Glad I picked this up and took it apart for you people to see inside it. I was quite pleased with what I found inside it. And it'd be nice if you give this a like if you enjoyed this talk. Please subscribe because there's videos coming out regularly. They're interesting videos. And if you wish to be notified, hit the bell notification. And for the rest, have an awesome day, folks. I'll see you for more. And goodbye.